Hello, this is Miss Goodwin, and I am going to go over today's belt work, which also served as a practice test for Thursday. So we are looking at trigonometry, and I'm going to go over these questions. So question 1, we want to solve for x, rounding to the nearest tenth if necessary. And x is right here. So our first step will be to identify our reference angle, which is the 60 degrees right here. The reference angle will always be given to you. Our next step is to label our sides. So the hypotenuse you're going to want to label first. It is opposite the right angle, which makes this long side our hypotenuse. Our next side is the adjacent. That is the other side that is touching our reference angle. Our last side is the opposite, which is across from our reference angle. So now that we have our three sides labeled, we need to compare it to the three trigonometric ratios. Those ratios are sine of our angle equals opposite divided by hypotenuse. Cosine of our angle is equal to the adjacent over the hypotenuse. And tangent of our angle is equal to opposite over adjacent. So as we can see, we have the adjacent and we are looking for the hypotenuse. Cosine has both the adjacent and the hypotenuse, so that is the one we are going to use to solve for x. So now that we know which function we are going to use, it's going to be as simple as plugging in our values. So we know our reference angle, so that's going to be cosine of 60 degrees equals the adjacent, which is 80, divided by our hypotenuse, which is x. To solve this, we just need to solve for x. So our goal is to get x alone. First, we want x out of this denominator. So I'm going to get it out by multiplying by x. And what you do to one side, you do to the other to keep it balanced. And that leaves us with x times cosine of 60 equals 80. Now we divide both sides by cosine of 60 to get x completely alone. And that leaves us with x equals 80 over cosine of 60. Bump that into a calculator. So here I have Desmos, so I'm going to do 80 divided by cosine of 60. Gotta make sure my calculator's in degrees, and I got 160. So x is equal to 160. So our hypotenuse is 160 units. And that is our answer. Let's look at number 2 now. So number 2, we are going to solve for x, rounding to the nearest tenth of a degree if necessary. So x is our angle, which means we're going to use our inverse trig, which is the flipped versions, are the inverses of all of these, which look like this. But it's basically the same principle to start. First, we're going to identify your reference angle, which we already did, and then label your sides as so. And then figure out which function we're going to use. We have the hypotenuse, we have the opposite. Sine has both of those, so we're going to use our inverse sine. So let me plug it in. We are looking for our angle, which I will use x for. Sine inverse of our opposite, which is 4.8, divided by our hypotenuse, which is 5.5. And we can just plug this into a calculator. Let's open up Desmos again. All right, here we go. So make sure you use the inverse sine function this time. And our numbers were 4.8 divided by 5.5. Close parentheses. And now when you're doing this, don't put in the letter x because you don't know what x is. But since you have it by itself, you could just plug in everything that's on the other side of the equal sign to get it alone, or to figure out what x is equal to. And this gives us 60.8. So our angle is equal to 60.8 degrees. And that's our answer. Let's look at number 3 now. Alright, so for number 3, we want to solve the triangle. First, let's solve for angle B. I think that would be the easiest. So that is our reference angle. Let's label our sides. That's the hypotenuse. This is the adjacent. This is the opposite. We have the adjacent hypotenuse, which means we're going to be using cosine. And because we're looking for the angle, we are going to use the inverse. So the angle B equals cosine inverse of the adjacent over the hypotenuse, which is the same as cosine inverse of 4.4 over 11. Use a calculator to get that. Okay. Cosine inverse of 4.4 divided by 11, and we get 66.4. degrees. Okay. Now for angle A, there's 2 ways we could go about this. First way is to use it as a reference angle, and then you would end up using the sine function to find your angle. Or we could just remember that all 3 angles in a triangle add up to 180. So to get A, we could just subtract both angle B, which is 66.4, and 90 degrees, because this is a right angle. And that will give us our angle, which I've gone ahead and plugged into our calculator, which is 23.6 degrees. And lastly, angle B, you could use 2 methods. You can either use the Pythagorean theorem, or you can use regular trigonometry. I'll go ahead and show both. So we could use the Pythagorean theorem, which gives us a squared plus b squared equals c squared. Sorry, there we go. So if a squared plus b squared equals c squared, then we know b is going to be equal to the square root of a squared plus c squared, which means b equals, no, that's supposed to be c squared minus a squared, my bad. 11 squared minus 4.4 squared, which if we plug that into our calculator, we get 10.1. So that's one way you could do it. You could also use trig. So we now have angle B and angle A, but let's just stick with angle B. We are looking for our hypotenuse, and we are looking for the opposite. We have the hypotenuse and the adjacent, so we can pick either tangent or cosine. I'll just use cosine. We know cosine of 66.4 equals the opposite B over, I lied, that would be sine, not cosine. 11. Multiply both sides by 11. We get 11 times sine of 66.4 equals B, which if you plug that into a calculator, you should still get 10.1. Yep, just about 10.1. If the decimals past here are a little off, that's to be expected because we did round that 66.4, but we still got 10.1. And we have solved our triangle. So with that one, you're just using your trig in both ways to solve the triangle. Now our last question is a word problem. From his eye, so we have a person here. Let's draw a picture. The eye stands 1.64 meters above the ground. Kashan measures the angle of elevation to the top of a skyscraper to be 33 degrees. So this angle right here is going to be 33 degrees. He is standing 385 meters from the base of the skyscraper. That's supposed to be 33. It's not letting me erase for some reason. My bad. And we want to know how tall the skyscraper is. Well, the skyscraper is opposite us. The skyscraper makes a right angle with the ground. Now it's letting me erase. Okay. And the ground is adjacent to where we're looking. So we're looking for the opposite and we have the adjacent. We'll deal with this with Kashan's height in a moment. But this opposite and adjacent mean we're going to use tangent, because tangent of an angle equals opposite over adjacent, which means tangent of 33 degrees equals the opposite x over 385. To get x alone, we multiply both sides by 385. And that gives us 385 times tangent of 33 equals part of x. So 385 times tangent of 33, which gives us 250.02. But we also have to add in our 1.64 because that angle is from our eyes. So that gives me 251.66. Or, yeah, 251.66, which rounds up to 251.7. And depending on how you rounded it, you might have gotten something slightly different. But that's okay. But Kashan is 251.6 or 7 meters away from this. No, the skyscraper is 251.7 meters tall. And that is it. Hopefully this helped out a bit. Have a great day. Bye.